And we are now recording.
I think it's recording now. Is it recording?
Yes, you're good to go. Go ahead.
Okay, great. Well, good evening, everyone. This is obviously week 8, or this is going to be the stuff for week 8. It's going to be an introduction to R that we're going to be going through tonight. This is obviously one of my favorite topics. My background, my undergraduate degree was in computer science, so I very much love doing stuff with programming languages. So I very much enjoy this section of the class, and so I hope you do too. In my particular section, I did do a survey ahead of time to see who had some programming background, and it looked like about half the class did and about half the class did not. The first thing I would just encourage everyone, even if you have some programming background, because it looks like most people had not done anything with R, is the best thing to do is just to set some time aside and just begin to play with these things, because me going through this tonight, I think it's going to be a little bit overwhelming at first, but I think if you just sit down and just kind of type in the commands and work through these slides on your own time after this presentation, you're going to see it come together really quickly for you. Okay? So let's start by talking a little bit about what is R. R is a statistical programming language. Okay, so it's a little bit different than Java or C++ or some other things. It was specifically put together for the purpose of doing statistics. It's actually a play on words. It's actually S was a proprietary language that came out before R, and people didn't like that. They wanted something that was free, something that was open source, and so they came up with this language called R in New Zealand in 1993. In order to compete with the commercial version of S. And so that's actually why it's named R, because of where it is in the alphabet. They said, we want you to think of R before you think of using S. So that's a bit of a play on words. And like I said, R is free, it's open source, it's available for different operating systems. As you can see, I'm using a Mac tonight, and I know that some of the other professors use Windows. It works on both systems. You can build graphs really, really, really quickly, and faster than you can do them in Excel in R. So it's got great visualizations. Good statistical methods are already built in. It can work out of the box, do some great stuff really, really quickly, much more advanced and much quicker than you can do in Excel if you know the formulas. Of course, you can save your commands and you can easily reproduce your results, part of scripting or writing with any kind of programming language. And of course, your results, once you script it, can be shared with others. One of the things that's really important about R is there's lots of documentation out there because there's lots of commands. You really need to know the commands in R really, really well. And it's really easy to forget those when you don't work in R every day. So one of the things that's unique about R is you got to read the documentation probably more so than you would with other languages because there's just so many commands that are rich and they're right there if you just know where to look. Reading the documentation is really important in R. Parallel processing. It works well in academic environments. For my job, I actually work for the National Cancer Institute, and we use R all the time in that environment as well. So it is heavily used in research. It can be used with other tools, including web tools, and you can actually web enable R. And it supports analyze structured data. These are things that you see in comma-separated files, databases, Excel spreadsheets, or unstructured data, things like graphics. So it can do all those things. One of the things that I think some people might see as a drawback to R is that there's no graphical user interface. This can also be seen as a really strong advantage to R because you can do a lot of things on the command line. And as you get more and more advanced, and if you begin to use Linux more in a really rich research environment, you might see those things become really handy. But if you're used to Windows and things, you might see this as a disadvantage. It does require some effort to learn, and you have to practice it. And if you know other languages, like many of the classes do, it will be a little bit different, and it'll be hard to remember those commands. But a lot of the things you know from other programming languages will also be true in R, and so you can Google them really quickly to figure out what they are. As I said before, reading those help pages super important in R. R, like many languages, is case sensitive. And like everything, it's not going to solve all your problems. It's not necessarily the best tool for every situation, but it will solve a lot of them, especially in these courses. You do need to update it often. Quite often, the packages are updated. I update mine about once a week when I'm messing around with R stuff. Okay, So like I said, it doesn't have a graphical interface, but there is a thing called RStudio that can be downloaded, which is an IDE, which basically stands for Integrated Development Environment. So it gives you a wrapper, if you will, around the language so that you can begin to manipulate the language in a more familiar way if you're using Windows and things like that. This IDE, I will tell you, is a little bit different than other IDEs that you may be familiar with. In that it actually implements some features of the language inside of itself. And at the end, I'll show you a demo, and we'll talk about that a little bit. And so those of you with some programming background will begin to see some of those little slight differences here that I think you're going to find are really interesting, and it can make for some some really good tools. And one of these things is allowing the preview of environmental variables and functions. Again, we'll show this to you in a little bit, but just note it for the time being, and we'll come back to this topic. In order to, obviously, to get to know R, like I said, you need to read the documentation. There's obviously online help at Big Data University, or you can try, learning about the programming languages like other ones. There's different websites. Here's a particular website that you can go to. There's some good information out there. However, in order to get it installed, the first thing you need to do is you need to download R, okay? You need to download the R package, and you need to install it. And you can do that from here. What you're going to do when you go in here, you're going to click on that, and it's going to say download, and it's going to ask you to choose a mirror. So you're going to choose a location. It's going to be like a list of states and a list of countries, and you're just going to choose one that's close to you, and you're going to choose a location close to you. If you don't know what to choose, just choose one of the government sources, if you will. There'll be something like Oak Ridge National Laboratory. Just download from there. It's a trusted source. We know that they have the latest copy. You can always download from there. Once you've downloaded R and installed it, it's just a package. It's going to come up and install like anything else on your computer. Nothing fancy required. You're going to download the RStudio, which is the IDE that I just referred to. So again, here's the web address. Just go there, download it, install it like anything else you would install on your computer. Of course, you do need to be an administrator on your computer in order to install this, which so if you have limited privileges, you may not be able to do that. So you do need to have a computer where you, like your home computer, where you know all the passwords. Okay? Again, once you have this all installed, no surprises. You just need to launch RStudio. Okay? For the purposes of this class, that should be sufficient. There's nothing special you need to do. If you happen to know Linux and you want to work on the command line, you can certainly do that as well, and you do that by just typing in the letter R on the command, and it'll bring up R there as well. But I think that applies to very few students in the class. Okay, so let's talk about the RStudio interface a little bit. As I said, it is a little bit different than other IDEs, and the first thing you notice when it comes up is you're going to notice the console on the left-hand side, which you see right here, this arrow pointing to that. You see the environment and history tabs over here on the right-hand side. I'm sorry, the console went on the left-hand side, environment tab on the right-hand side. And then you see these tabs down here, files, plots, packages, help, and viewer. One of the first things you're going to notice is the first thing it's going to tell you is the version of R you're running. In this case, this screenshot was taken with 3.2.3. I believe the latest version is 3.2.4. R always has cute little names, little snarky names that go along with it. So this was Wooden Christmas Tree. And so it'll give you a little name like that, and that's to tell you what release you are. Okay, and then you see a little prompt right here. Again, if you're familiar with Linux command line, this is the same prompt you would see if you were in the terminal. Environment, history tabs, files, plots, and packages, and helps. We're going to talk about that as we go through this a little bit more about which each of these things do. Okay, so like I said, the console comes up, the prompt. Like I said, is where you can actually type in commands just like you're on a command line interface there. And so instead of running a script, you can just type in a command and just hit enter, and it'll run that command immediately after you type it in, and it'll show you the results right below it. Okay? That's what you can do in the console. And you can keep doing this over and over again. On the right-hand side, we talked about the Environment tab. And the Environment tab is what tells you what is in memory, or what variables that you have in memory that can be reused throughout your program. So this is a little bit different than more traditional languages, Ruby, Python, or things like that, where once you executed a program, there's not necessarily anything left in memory you can continue to access unless you did something special. In R, it'll put the stuff in memory, and as long as you're in RStudio, you can see those things there, and you can continue to manipulate them as long as you have the IDE up and running. So it's really, really handy. In fact, you can even click on it and it'll bring up a table and all kinds of things for you that we're going to show you a little bit later tonight. The history tab is pretty useful if you don't write a script. If you're just working in that console and you're just typing in things, you're like, oh man, what did I just type in? Or I don't remember, it was like 10 lines ago, it worked really well. Well, just click on the history tab and it'll show you all the things you've typed in this particular session. When you do leave this particular session, so what that means is you close down RStudio, you will lose this history. So you need to save that out or something if you want to save what you did. But really what you should be doing is you should be working from a script that we're going to talk to you about later. Okay? And then you don't have to worry about that. But that is the history of what you did inside the console, or what was executed most recently. One thing I should point out really fast while I'm here, let me go back a slide, is see this little broom right up here in the right-hand corner? There's a little broom. It does what it implies. It sweeps up, so it's going to clear all that information. So if you click that and you don't want to keep that history more, it's going to clear your history. If you want to clear everything out of memory, click that little broom and clear that stuff out of there. Okay? So just keep that in mind. That broom may come in handy as you begin to work through your different assignments. Okay, the Files tab. The Files tab does what you expect it to do. It shows you the files in your current working directory. A working directory, like the slide says, is a hard drive location where R is looking for the files that you're going to want to load. And this is an important concept because you're going to need to load a data set in order to finish your assignments. These are going to be comma separated most likely. And so you're going to need to make sure that wherever you save that file is your working directory as you get to that location. The Plots tab. Like I said, R is wonderful at producing graphs quickly and simply and easily. Okay, so the Plots tab is where those images go when it creates that image. It sticks it right here. Again, there's a little broom. You can clear that out. You also have an export button there where you can export it as a PDF or as a JPEG or something else like that. You can, of course, zoom. And then this little arrow here is, and I'll show this to you a little bit later, is if you produce multiple images, it's only going to show you one at a time, but you can like flip through all the images it created right there. So really kind of a handy little thing there. The Packages tabs. Okay. The packages, when you get R out of the box, there's certain methods and functions that are all built in that you can just execute right off on your own. However, there's a lot of developers all over the world, and all these developers have cool ideas about things that they want to write a package for. Or maybe even your professors have a package they want to put together. The NCI has their own packages we want to put out. And so we're going to bundle all of these, our special methods, if you will, into these packages. And so once we bundle them, all these methods into a package, we can like publish that package out on the web. And then other people, such as yourselves, can download and say, man, I want to use this package that Brent wrote for the NCI. And I want to download it, I want to use it. And so that's what packages are. They're just a collection of methods and functions from different developers. And so that allows you to extend the functionality of R and to reuse a lot of code that other people have already written, so you don't have to reinvent the wheel every single time. That's what packages are. The way they work, though, is it's going to show you all your packages that are available right here that you have installed on your computer. So just know that that's what the packages are. There's the update button for that. We'll talk a little bit more about how to load these as we go through the presentation, but just know that's what's going on with the packages. The Help tab, incredibly useful in R, more so in R than other languages, is exactly what you think it is. It's help. And you come up here, you just type in the command that you're looking for, and it'll tell you all about that command down here. Okay? Are there any questions at this point? Okay. R syntax. The commands are case sensitive. Okay? So case sensitive just means upper and lowercase matters. You can put spaces throughout, inside of different functions and methods as you would like. They're not going to affect the meaning of the sentence. They do affect readability, though, and so that's why it's here. Okay. Functions may have both required inputs, they may have optional inputs, or they may have both, and we're going to see examples of that as we go through. Missing values inside of tables, inside of a matrix, will have the NA in there. So just think about an Excel spreadsheet. If you want to just picture something in your mind, just imagine if you have a cell that's empty and just put NA there in your mind. Just say, there's a cell there, I'm not sure what goes there, just put NA, so it's something empty. So that's just a missing value. Just know that's what it means. Boolean, anytime we talk about Booleans, we're talking about true and false. So Booleans can be represented by false or F or true or T. It means the same thing. I personally prefer that spelled out, because I always tell my programmers that being verbose makes it more readable. It's my personal preference. Each to their own, though. All variables are treated as vectors, even if they have just one value. I'll show you that a little bit later on, but just keep that in mind, and we'll see what that means as we go through a little demo here in a slide or two. The assignment operator is this arrow. So it's the less than and dash operator, okay, which makes this arrow look, here. So do not use equals. So if you're familiar with other programming languages where you would set a variable equal to something, don't use the equal signs in R. Use this arrow operator, okay? And of course, near and dear to my heart is it supports regular expressions, which will be really, really important in the future. Okay, let's look at some actual R commands. Characters. R considers something like someone's name like that. If you asked it, what kind of data type is this? It would come back with character, even though for those, like I said, are familiar with other languages, that looks like a string to you. Okay, so just keep that in mind. But characters can come in double quotes like that. Okay, if you have a single character, you can put it in single quotes. The arithmetic operators are plus, like you would expect, minus, division, multiplication, and to the power of, just like you expect. Nothing fancy there. Of course, like you would expect, you can combine operators, and you can use RStudio as a calculator. So if you just type in 2 plus 5 on that console prompt right there, you get back exactly what you would expect to get back. You get back 7, okay? Or 16 divided by 4, you get back 4, okay? Or 15 squared, we'll get back 25. Okay, just like you would expect. You can use it just like a calculator. Now, 1 minute ago, I said that all, let me just flip back a slide right here. I said all variables are treated as vectors. Here you can see a little bit of example of that. You can see this 1 out here in front. That's kind of telling you we're talking about the first row, the first column of this object that is in memory. That's this unnamed object, essentially, in this particular case, because there's no variable here. And so that's what that 1's referring to, and you're always going to see that. That's not part of the solution itself. It's just something that's always there to tell you what's being shown, and you'll get familiar with it. And again, it's a little bit different than other programming languages because you might have expected a 7 just to come back on the command line by itself, but just know it's actually going to be 1 in brackets followed by the answer, okay? So I just want to draw that distinction here. Here you can see us assigning to the variable x. You can see us going 22 plus 5 and assigning it to x, okay? And then if you want to print something, while there is a print command, and there are some different things, also like a cat command in R, you don't have to use those. Those have special meanings. You can simply write the variable on its own line and just hit enter, and that will also do a print to screen. So in this case, you see we assigned x, somebody hit enter, and then they said, okay, well, we'll go ahead and print that, and they typed in x, and they came back with 27, okay? So a little bit different. If you're not familiar with other languages, it'll be perfectly natural because you have nothing to compare it to, but for those who are, it may be a little bit different than what you would have thought. Okay. Comparison operators, greater than, less than, greater than or equals to, less than and equals to, greater than or equals to, equals. Okay, so equals is the same thing as saying the value on the left, is it equal to the value on the right? And it returns a Boolean, true or false. So really, really important. So just like greater than or less than, is going to do a comparison and say whether the syntax is true or false. Equals equals does the same thing, okay? And same thing with the bang equals. Bang equals means not equals. Anytime you see a bang or an exclamation mark, that means not in a programming, in many programming languages, okay? So you can see an example of that. Is 2 greater than 4 false? You know, is 7 is not equal to 8 true? Okay, so you see the example of that. It makes perfect sense. And again, there you see the 1 inside the brackets. You can, of course, build more complex things. One thing to note is if you want to do an or, to say, you know, I want you to say, is 2 greater than 4 or is 7 not equal to 8, you could put a bar in between. That bar means or, an and sign means and. Okay, and it's a single bar and a single and. Again, for those who are familiar with Java, you know, where you have to put doubles, here it's only single, there it's double. The operator bang, which is not, negates a logical value. We talked about that already. Does that make sense to everyone? Any questions? Okay. Vectors. The best way to think of a vector, and this, you know, I like to make things as simple as possible for people to understand. So this isn't technically mathematically true, but I think it's true for everything that we need to do for anything in these classes. And it's actually, at work, we even use the same language. So a vector you can just think of as a list if you want. It's just a list or a single row of values. And so you can see that here, A, B, C, D, and E. It's a single row of characters. Okay, each separated into their own little cell if you want. If you want to imagine like an Excel spreadsheet, where, you know, on the first line, or on the first cell you had A, on the second cell you had B, on the third cell you had, you know, C, and on and on. And you can see here that we took this list and we put the C in front. C means combine or concatenate if you want to use a big word. But really, you know, combine these things and put all these values into this variable X. And you can see here that when we print X on the screen, that we're going to get back is A, B, C, D, and E, each separated. But again, you're going to see the 1 because that 1 is going to be the means that just that one row. I see that there's a hand up. Is there a question? No questions? Okay. And again, when you put together a list, you can reference that particular list by the cell, if you will. If you, again, just continue the analogy a little bit here for you. By just putting the number of that item that you want to get off the list in there. So you can see in this case we stored A, B, C, D, and E inside of this variable X. And here we want to get the first element out of X. And so X, and we put inside the brackets the 1, it returns just the A. Okay, so if I put a 3 there, it would return the C. If I put a D there, it would, I'm sorry, not a D. If I put a 4 there, it would return the D. Then you can do this cool stuff you see on the next line where you can put a colon in between it, and this can get really powerful. This says, return to me everything that's in cell number 2, 3, and 4. And so I get B, C, and D in that case. Okay, so everybody see that, how that syntax works? Okay, so the next part here is length. The length, if you pass in the particular vector that we're working with, will return the length of that vector, and that's just the number of elements it has in it. So in this case, it has 5 elements, it returns 5. In class, in this case, it's going to return a character. It's going to say this is a vector of characters. Okay. Okay. Any questions? Okay. Things you want to do with those vectors, you're going to want to manipulate them. One way you can manipulate them really simply is just to reverse the order of them. That's what the rev command is going to do for you. Or you can use the order command to sort the elements. Okay, and so here we can see it's starting to combine them. Okay, so we're going to order X. Okay, using the help pages. Let's go through this really quick. This is if you need help with a particular item. What you want to do is you want to, and you don't have the help screen right in front of you, and you're just at the console, you can use the question mark, if you will. Okay, the question mark we'll do the same thing. It's going to bring up the help page for you. So it's a question mark followed by the name of the command that you have that you would like help on. Okay. Alternatively, you can enter the command help at the console, help, and then followed by the name of the method that you need help on. And if you don't know the name of the method you need help on, you can use apropos. And what's important here is that you put it inside of quotes, because what this is going to do, it's going to return to you a list of all possible methods that have, in this case, in this example, sum inside of it. So if you type in apropos sum, it's going to give you a big list of things. And then from there, you can choose the one that you need help on. Okay? Makes sense? Any questions? Okay, great. Okay, we talked earlier about the working directory. Okay, inside of RStudio, it's going to elucidate, or it's going to have on the screen. It's going to tell you the working directory. It'll be up in the title bar. Okay, but you can set the working directory, and in fact, you should set the working directory inside of your script by using the command set wd, and then the working directory you would like to set it to. In this particular case, this is obviously not a Mac user who wrote this. This is somebody using Windows, so you had to put the directory drive there. If you are a Mac user, you will simply take off. It would just be like this. That's all you would type in. Sorry, like that. Okay, to give you kind of the same idea. Okay, so that's the way it works. So if you're in Windows, you need to use the drive letter. If you're on a Mac, so you don't have drive letters, and so you would follow the standard format you would for directories. Okay, but the same command works either way. Okay, that's setting the working directory. And again, you're going to need to do this in order to get out your particular data files. Okay. One of the things I also mentioned before was that the IDE itself, the RStudio, actually implements some of the language itself. And so some of the things that you can do in commands, you can also do by running different tools inside of the IDE. And one of those is actually setting the working directory. So instead of putting in your script set working directory, you could go up to the session, click on set working directory and set it from there. You could do it that way. I don't personally recommend that because it's not repeatable, and next time you come in, you may have to be like, oh, I forgot to set that working directory. Whereas if you have it in your script, it's only 5 characters, set WD. It's easier just to type it in. That way, it's always there, and I know it's going to work. My personal preference, again, just if you choose to do it this way, just make sure that you set it every single time. If you want to see a list of all the files in your working directory, the dir command does that. Obviously, from what we talked about, without using the dir command, you can see those files over on the right-hand side because it's going to have your working directory in that Files tab. Okay, but if you'd like to list them out on the screen, dir will do that for you. If you'd like to know what working directory you have set, then get working directory does that. And in this case, you can see the working directory that was set in this particular case. Okay, and that'll return that to you. Okay. Loading data. So one of the things that's really, really common is that you're going to want to load things that are separate, where there's data values that are separated by some separator. In this particular case, CSV is comma separated. Whereas if it was TSV, that would probably indicate tab separated. Okay. And so you can use this command, read CSV file, and what you do is you basically pass in the file name. Pass in the full file name. You don't need to pass in the full path because remember, you've already set your working directory. So hopefully we're in that same directory. Okay. You set the head to equals to true. Okay. If the first row is actually labels for each of those columns. Okay, which it typically is. So imagine again, picture in your mind the Excel spreadsheet. Okay, and right at the top you might have a spreadsheet for flowers. Okay, and so you might have like petal length, flower color, species of flower, things like that. Imagine those are the first at the very first row, and then for each for each column. But then for each row, so let me repeat that. For each column, those are where those are. But for each row, those might be different records you have for things you've recorded from different flowers, if you will. So just know that if your first row is the column headers, then you need to set that to true. If it's not, set it to false. Okay. The separator, obviously, you don't need to put that in there if you're running CSV because it's already set to that. Okay? What this is going to do, when it reads in data that is in a CSV format, it's going to read it into something called a data frame. Okay? A data frame, as the slide says, is similar to a matrix. But unlike matrix and what we did in linear algebra, a matrix, if you just imagine that from undergrad, where you had 1, 2, 3, 4, 5, 6, those were all numbers, okay, typically in your data in your matrix. In a data frame, it allows you to load different data types. So you could have a table, if you will, that has numbers in one column, but has values in another column, such as, like I said a second ago, species. You might say, well, this is an iris, or this is a rose, or this is a tulip. And then next to it, you could have sepal length, and it might say, 12.5 millimeters. Okay, so this is why R is really, really powerful, because you can do some things with this data type data frame that you really can't do in other languages very simply. So there's some really cool features there. When you're naming your variables, up here the variable cars is being named, okay? Just know that you can't start those variable names with special characters, okay? And again, you can imagine why you can't start it with a bang, because again, we already said that's a special character and it means not, so it has a special meaning. One thing that's really common in R that I'd point out is this dot. It is very common to put a dot in your variable name somewhere in the middle. But that doesn't mean like class or anything else like it might mean in another language, okay? It's just part of the name. So I'll just point that out. We're going to talk about dollar here in just a second and what that means and how to access that, okay? So that has a special meaning too. We'll go through that. But just know that, when you're naming your variables, name them sensical names, okay? Another way to import the data set is, I showed you the way I think is preferred because it's in your script. But the other way to do it is you can import your data set here from inside the GUI itself. And so you would just go up to Tools, Import Data Set, and it's going to look just like Excel when you're bringing in a CSV. It's going to show your data over here, your input file, and it's going to say, what's the separator? Yeah, there it is, comma. And it's going to show it separated like that, and you can kind of manipulate it from there. I see a hand up. Is there a question? Any questions? Okay. Everybody still there? Okay. Okay. We'll keep going. Okay, so this is how you would load a data set. Again, if you have a question, just feel free to unmute yourself and just speak up, and I'll be happy to answer it. So just feel free. But we will be doing a demo in case you're like, wow, this is a lot of information. I'm gonna do a demo. I have a script for you guys so you can play with this. So hopefully it'll make more sense when you actually see the demonstration. So once we load our data set, there is a view command. Notice it's uppercase V. If you type in a view at the console and you type in the name of your data set, it'll bring up an Excel-like window, if you will, and it'll show you your data. This is something very different to R from other languages again. And inside that view, like window, you can click on like filter, you can sort your data, and you can do all kinds of things you couldn't do in other languages because it's all inside this IDE. So very, very handy. And as you can see on this slide, there's a lot of information it's going to give you about that. One of my favorite features is the filter. So if you click on that, it allows you to say, like, I only want to see sepal length, for this particular flower, where everything is greater than 5, and you can just move a little slider back and forth. I'll give you a little example of that. Okay. But just know that that's how that works. The other thing I should point out about R is you're probably wondering, like, where did this flower data come from? You just kind of brought that out of the blue. R has some built-in data sets already there available for you, and iris is one of them. Cars is another one. So you can have something to play with. So just know that if you use iris, it's already a data set that's available for you to use. And so you could go in right now if you have R installed, and you could type in uppercase V, IEW, lowercase, and then type in and put iris inside of brackets, and it'll bring this up for you immediately. Okay, as long as you have R installed. Okay, and RStudio, of course. Okay. Okay. Head, and then the name of the data set that you're looking at, or the data frame that you're looking at. Will do kind of what you would expect if you're a Linux person. It'll bring back the first 6 rows of data for you as a default. If you'd like to bring back more rows, you can just specify the number of rows you'd like to be brought back. So in this case, we overrode the 6 with 10. And so we said bring back the head, meaning the first 10 rows in this particular case. So you can imagine what the alternative command to this is. It's tail. So tail does what you think it would do. It brings back the last 6 rows, okay? And you can override that just like you did before. Okay. A few other things you can do with data frames. There's a command called dim, which stands for dimensions. Okay, that tells you how many records do you have, which is the number of rows you have, and how many columns you have, which is your variables, if you will, or your the things that are descriptive. Or your observations is another word for rows. So if you see observations, it's referring to rows. Okay. So in this case, we have 150 data rows, and we have 5 variables. Okay, which means 5 columns. Okay. And you can see that here. There's another command in columns, which is number of columns, returns back 5. Notice these 5s match. Makes perfect sense. Same thing with number of rows, or it returns 150. So it kind of does what you would expect it to do. Names does what would be expected. Names returns back the names of the variables, or the names of the columns in this particular case. So we got back sepia length, sepia width, petal length, petal width, species. Okay. Notice the dot also. Very common syntax. People like to do that in R is separate things with dots. Okay. Display the variable names in data row names and run attribute command. I'm sorry, I skipped over a slide here. Or attributes. Attributes is the command that's being shown here. If you'd like to know everything about your particular data set that we just described, like such as what are the names, what are the unique rows, and what data type is this, you would run attributes, and that's what's being shown here. So in this case, you can see that we got back to 5 columns, and then we got back each of the rows, and this is just wrapping. So it's 1 through 25, and it's 26 through 50. And so it's lines of 25 each right there, saying what is the first value there. And then the class is data frame, and we already talked about data frames. R is a little, some languages you need to really know what kind of data you're working with. In R, I would say this, when you're working with numbers, just think of them as that, as numbers. You don't have to necessarily distinguish between a floating point and an integer. But in case you ever see those terminologies being used, I can't think of, when we were putting this together, I couldn't think of an example, but we thought of it, it was just good to kind of introduce these terms to make sure there wasn't a time where this would come up. But if you see int refers to anything that's not a floating point. So it's 1, 2, 3, 4, 5, whereas a floating point number is something like 2.346 or something like that, something with a decimal in it. I don't think it matters in R, but just keep that in mind. If everyone ever refers to it in documentation, and it will refer to it in documentation, that's what it means. A factor, though, is very much an R term. The best example I can think of to make what a factor is, tangible to the class is the idea of months. Where January is the first month, February is the second month, so it's almost like you have a name value, but it's a name number combination. Okay, so anytime you refer to 1, it's the same thing as referring to January. Anytime you refer to January, it's the same thing as referring to 1. That's kind of the best way I can think of factors, and we're going to see an example of that here in just a second. Another example of factors is actually, if we went back here to the species on the iris table, species would come in as a factor. Okay, because what it is it's something we call categorical, and that means it's something that has, it's a column where there's categories. Another example of that might be gender, for example. If you had a column for gender and the answers were M or F, or male or female, that might be considered categorical because there's 2 categories you can be in. Or in cars, you might say a category of cars is SUV, and another category of cars is a 4-door sedan. So think about it in those kind of terms, okay? Just like I said, one of the things is as you play with it, you'll become familiar with it, and it really won't propose much of a problem, I don't believe. Data frames, we already talked about data frames a little bit. Again, a data frame is really what you can just imagine in your mind, this is the easiest analogy I can think of. It's just like an Excel spreadsheet where you have data in it. Okay, we've been playing in Watson Analytics the last few weeks, so you know when you go into that, the refined view, and it looks like that spreadsheet. You can kind of think of that as what a data frame looks like too. Class, we talked about that already. Class is if you're not sure what a particular column is or how it's being manipulated, you can use the class and it'll bring back and it'll tell you what kind of data type it is. So in this case, character for X. There you notice that we passed an iris and it came back as data frame. So again, you can kind of think about from our Watson Analytics experience in there. Sometimes sometimes it might come in as the wrong data type, like if it was. If it was supposed to be, if it was a 1 and 0 and it was really supposed to be, categorical, meant something, you probably needed to change that instead of keeping it as a number. So you can think about those kind of things as you go through this. Is numeric is if you want to check to see if something's a number. That's what that'll return true or false to you. Is character? Is it a character? It returns true or false to you. Okay. So here you can see that someone's passing in the iris, and you see that $sign right there. That $sign right there is how you access a particular column inside of your data frame. Okay, so we talked about data frames, and before, up to this point, we've just been manipulating the data frame as a whole. Okay, but now what if I just want to get to one particular column? Well, like I said, the way you do that is with that $sign. Okay, so that means inside of iris, you should see a column called sepal length. Okay, so in this particular case, I just want to know, is sepal length numeric? And it says true, okay? Whereas if I just passed in iris, it's going to come back probably false because iris is a data frame. It's not numeric, okay? So does that make sense to everyone? Any questions? Okay. The structure command. Structure command displays the structure of the data frame you're looking at. Okay, so remember I said that rows can also be called observations. You notice right here it says number of observations and it says 150 OBS. That just means 150 rows. Number of variables, again, that's just your columns. Okay, so in this case there's 5 columns. Okay, here's the variable names over here. And so there's some various different data. You can see right here that the species, like I was telling you before, notice it came back and it says factor, and it says with 3 levels. Okay, so in this case, that means there's 3 different species of flower. Is there a question?
Yeah. Can a vector contain elements of the different data types?
Okay. I'm sorry, repeat the question. I didn't quite understand you. Say it one more time.
Can a vector contain the elements of different data types, or is it it can contain only one data type?
So a data frame can contain different data types. Is that what you're asking? So this is a good example
of vector.
Yes.
Can a vector contain elements of the different data types?
I'll show you an example of that here in a second. The answer is yes, it can, but there's some I'm not sure what the right word is. There's some caveats. Okay, but really when we're talking about different data types, I really think in terms of data frame, that would be the best advice I can give you. Okay, because with vector, it doesn't always perform the way you think it would perform, and I have an example of that actually in my demo code. Okay, so here's the data frame, and notice it says number, factor. So yeah, different types. Okay, summary. If you have a data frame and you pass it into the summary command, it's going to give you all kinds of stats really quickly, really easily. Median, mean, your first quartile, third quartile, max, min, all that kind of stuff immediately calculated for you. If you get really good at R and you get good at the command line, you can do things faster in R than you could do if you had to, take this data into Excel or something like that. It would take 10 times longer in Excel. So this is a really quick way to find out information about things. Okay, so that's what summary does for you. Summary doesn't just work on the data frame itself. You can just pass in a particular column or a particular variable into that data frame or into that summary command and get back just the statistics on that particular one. And that's what this is simply showing you an example of. Again, you name of the data frame, followed by the $sign, followed by the name of the particular column, okay, or the variable name. Okay. Some more statistics, range. standard deviation, mean. We got mean before, but this is another way to get specifically back mean. And unique. Tell me the unique types that are there. Unique is actually fairly useful. Okay. So if you just want to know what all the unique records are. Okay. Again, just playing with these things, you'll begin to learn them. Okay. The data editor. The data editor. Now, this was new to me. This is something I got taught in. I did not know. The reason why is what I've learned. The data editor is something that allows you to manipulate the data inside of the RStudio IDE. Okay, and you open it using this command called fix. And so fix and then the name of the data frame. And it's going to open up a separate window and it's going to show the data in there and then you can edit it. And I thought, man, how did I not know this all these years? And here's the reason why. Is if you're using a Mac or a Linux computer, it will work, but you have to install other software to make it work. And I will tell you, it doesn't work great. I can't speak for Windows. I think most people here are probably using Windows. Whereas most people I regularly interact with typically use Linux. So if you use Windows, you can do it this way. I can't really speak to it in any great depth, but that is just an option for you. Again, I don't really recommend it. I don't recommend using any of these things that you can't script because you may want to repeat yourself later and you don't want to have to remember to come in here and do some editing. But just know that using fix, you can bring up this data editor and you can do things that you see in this slide and in this following slide here, and you can rename things. Okay? Again, if you're using a Mac, you can get this to work, but you're going to have to install like the Quartz X11 and some other stuff that we won't get into in here. And it's nothing you can't do just as simply writing a script with one line, one command. Okay, but it is interesting. It is there. If you'd like to use it and like to play with it, it's certainly available to you. Okay. If you have a column or a variable that you're not interested in using, you can just set it to null. A null is essentially a way to remove it from the set, if you will. And this is how you would set that to, so you'd say your name of your data frame, followed by the $, followed by the name of the variables you want to set to null, and just pass in null, and it's going to set the entire thing to null. Okay? It won't set just a single cell, it will set the entire column. Okay. Subsets. So say we want to extract a particular set of rows and columns from the data frames. Now we talked about head and tail earlier, and so you might be getting to get a hint of how this works, but the way you do it is you type in the name of the data frame, and then inside of brackets you put in the row and the column, okay, that you want to come back specifically. Okay, so in this particular case, you're going to see that we want rows 1 through 6, which is why there's a colon in between. So rows 1 through 6, comma, and then there's nothing. And that's kind of strange syntax. What that means is I want to get back rows 1 through 6, but I want to get all the columns, okay? If I had specified 1 through 6 and I had put a 1, that means give me back rows 1 through 6, and then only return column 1. If I had done 1 colon 6 comma 2 colon 3, that would have been rows 1 through 6, columns 2 and 3. Okay, for each of those. And I'll show you an example of this in our demo, okay? But just know that this is how you access individual cells or a group of cells inside of a data frame, okay? Very, very useful. You will use that a lot. It won't be terribly confusing to you, though it may be at first, okay? But just know the first thing is the rows, followed by columns, as it specifies here. Okay. Sometimes you're going to get data sets that have cells with missing values in them. Okay, really, really common. And sometimes you need to clean up your data before you can do statistics on it. Because I mean, how do you get the mean for a particular column if there's a cell that's got nothing in it? I mean, what is nothing? Or what is NA? You can't do math on it. So the way you do that is you can use this NA omit command to remove these things, to eliminate these cases. Or if you don't want to eliminate them, when you run the command, there is a way just to say na.rm equals true, and I'll show that to you. I think it's on the next slide, actually. Okay. Here's a trick also. This isn't a particular command. This is actually a bunch of commands all put together. So if you want to find the number of rows with missing data, type that in. And if you want to parse that apart, you can figure out what that's saying, because you can see that I'm using the not, I'm using this thing, complete cases, and I'm using the data frame. They're all embedded right there. But that's a really quick syntax for you, if you would like to figure that out. So just replace where it says cars with whatever the data frame is that you're referring to, and that'll do it for you. So let's go back to what I was saying about the NA emit, okay, because I think that's a little more practical. So if you have the mean, like I said, and you want to get the mean for a particular column, and it comes back and says NA, that means, oh, there's some data values in here that are bad. But if I don't want to get rid of them completely, like it showed on this slide, using the NA emit, I want to leave them in there, but I still want to do my calculation, you just do NA.rm equals true, okay? Remember, T or true would work. And what that'll do is it'll do the calculation and it'll ignore those others, okay? So that's fairly handy if you find yourself with data that's incomplete. Here's some more advanced commands. You can see we get into ordering and things like that. You can use the ordering command to sort the data on the data frame. The default sorter is ascending, okay, which means it's going to go from lowest to highest, okay. And so that's what you see being passed in here. So you're basically you're sorting the rows by sepal width is what this is saying, okay. Sort the rows by sepal width, in ascending order. Okay, and then just print off what you find there. Okay, now if you want to do it in descending order, you put a minus sign, and so you just do the exact same thing, just put a minus sign right there, and that'll make it descending. Okay, so you can see how the largest is here, and it goes down to the lower. Okay. Okay, table. The best way to think about this is a pivot table. It's just a summary of all the things that you have in your data frame. So if you had, like, imagine again an Excel spreadsheet where you had a group of cars that you're trying to work with, and some of the cars are gas and some of them are diesel. And it's like, I want to know how many cars are diesel and how many cars are gas. Well, you can do this thing called table, pass in the name of your data frame and the name of the variable that you want to have the summary on, if you will, or the category on, if you will. So in this case, we did fuel type. Okay, so this comes back to this. There's 20 with diesel. There's 185 gas cars out there. Okay, really, really useful. But what really makes it useful is this next part, is that you can put a comma and then you can do, like, I want to know, how many of diesel cars are 4-door versus how many diesel cars are 2-door versus gas and all those things. And so you can get this pivot table kind of effect going on by putting that comma there and putting another variable name. Okay. Or if you wanted to see what, proportionally, what percentage of your cars, you can do prop.table. And then pass in the table command that you saw from up there. Okay, so you can see that this command here in the middle, right here, should be the same as the command right here, and this is a new function, prop.table, that you'd pass that into, and it'll give you the proportional table. Okay, kind of cool, something to play with. Okay, I talked before about libraries in R, okay? And I said, one of the things that you can do with these packages, these things that other developers have written, other things that, people have done, is you can see what they are over there, and you can install them, but in order, you got to get them installed somehow. Well, the way you do that is with this command, install.packages. And you can find out, you find the packages online, you would Google around for your package. Once you just determine your package, you would just type in install.packages, and you put the name of the package right in there. And here's an example of that. That's what would go in. That would install the package on your particular machine. However, once it's installed on your machine, you still need to use that package. Okay, so now it's going to show up over here in your packages. But in order to use that, you can either check it off. If you check it off, then it means it's loaded in this particular section, or you can use the command library. And inside your script, you'd say library, and you'd pass in the name of the package that you want it loaded. I personally always use library. I never use the check mark because I just don't think that way. That's just me. And again, I like to have all my stuff scripted. So just know that's how you would load packages. And so if you need different statistical packages you want to use, there's some other stuff out there. This is how you get those those commands to be accessible to you, or those methods to be accessible. Okay. Now I've been kind of telling you guys that graphs and things are really, really simple to do in R. And so this is our first example of a graph in R. And I think right here you're going to see, just how simple this is. And so we've been talking about this iris data frame. The iris, like I told you, was built into R. It's available to you right now. And here you can see we built up a plot, a dot plot, really quickly. I passed in sepia length and I passed in petal width, and I just want to do a dot plot comparing these two. And it's as simple as that. It's as simple as typing in plot, and it'll automatically put this, produce this graph for you over in the plot section of the IDE. Okay, and so it comes back with that information. Okay, so that's a really simple example, but you can get more and more sophisticated. So you want a histogram. That's what the hist function does. You can type that in, and you'll get back a black and white one. If you want it to be in color, you see you could pass in this variable col equals and pass in the colors. Notice I'm using the concatenate or the combine command there, and so it's going to go in order. And so it should go red, orange, green, blue. And then sure enough, if you look at the histogram, it goes red, orange, green, blue, red, orange, green, blue, just like we passed it in. Okay, and then it starts repeating itself. Okay. So that's as simple as it is to produce graphs in R. Can do things very quickly if you want to see a plot of something. Also, you notice when you pass in variables, if it's optional, you can pass it in where you pass in, say, the variable I'm passing in right now is this thing called col, which is color, C-O-L, and then equals to this. Okay, so that's something that's a little bit unique to R. Some other languages allow you to do that, but it's not as common in every language where you can actually name what you're being passed in, what's being passed in. And so that's an optional command to be passed in. As you can see up here, we didn't pass it in, and it works fine. If you pass it in, it's optional, and you can name that, and you can pass that information in. Okay, well, that's an example of an optional command. Here's a pie chart for you. So pie chart, we use that table idea that we used before, and so we actually combined commands here. We took the table command that we learned a little bit earlier, based upon body style, and then we said, give me a pie chart of the body styles, of the car. And so here's our pie chart that was produced. Really simple. Okay. Finally, we've been talking about, doing all these things on the console, where you type things in over and over again. And I've been talking, as I've been going through this about the need to put things in scripts. Really important. What you want to do is you want to write a little text file, and your text file is your script, and you want to give it this .r extension, okay? And so this is your file of all your commands, and they're run in a particular order from top to bottom, and it allows you to do everything in a repeatable, reproducible manner, and it's what allows you to share with your professors and and with the world essentially what it is you've done, okay? And so you produce these things inside of a script, and so that script is the fourth panel that we haven't introduced yet in IDE. At first there were 3 panels. If you say new script, it's going to come up above the console, and we'll see that here in just a second. Okay, so that's what a script is. Okay, it's just a text file with an R extension, with a .r extension that lists all your commands. That's that simple. Finally, to get out of R, if you're inside the IDE, you can just go up to the top, file, quit, if you're on Windows or whatever. But if you want to do it on the command line, you just type in quit, and that will get you out. Okay. Are there any questions at this point? Because I've got to take a drink of water. My voice is giving out. Okay. If there's no questions, this next part, I'm going to put all this together for you, and I'm going to show you how to kind of begin to do your assignment number 4. I will say that the point of this demonstration is not to teach you the statistics, and so I'm not going to describe the results. Your professors are going to be describing the results for you in classes and how to use them specifically. What I'm going to be talking to you here about is the syntax and begin to get you the idea of how to use R to solve your assignment number 4, okay? But again, the professors are going to talk about the specifics of what these stats mean and how to use them and what all these numbers up on the screen are going to be. So when you see that, don't let it blow you away. Just take it in. Just say, I'm here to look at the syntax and just kind of look at the order of events, okay? And so you can always come back and refer to the slide later as you work through your assignment, and work from there, okay? So the first thing we want to do is we're going to do a multiple linear regression, okay? And so in order to accomplish this, just like to accomplish anything, we're going to need to do a series of commands. So we're going to use some commands that I've already taught you, and then I'm going to introduce 4 new commands for you. This one called set.seed, sample, lm, in step. Okay, set.seed is going to set a random number generator. Sample is going to break apart your sample into test and training sets, or any set you would like them to. LM is actually going to do your linear model for you, and step's going to find the variables of significance for you. That's a lot to take in, and as I said all along, is really important in R is using the help feature. So if you want to know more about these and what options are available, this is a great opportunity to use that help thing. So go over in the RStudio and type in help and type in step, and to see all the options that are available to you and all the things that are written about it, okay? Because it's a whole presentation in and of itself just to describe what each of these can possibly do for you, okay? But these are basically the commands you're going to need to run, okay? So the first thing you're going to do is you're going to get some set of data, okay? And so I got this data from Elena, and this is some cholesterol data for people. And so there's some medical terms up here. Again, don't worry about what the medical terms are. Just know that there's these are columns, okay? And notice that the first row is the header, and it tells you what each of these columns stands for, okay? Some of them are obvious, age and sex, whereas phthalates may not be obvious to everyone as to what that is. And some of these are like resting heartbeats and your maximum heartbeats and some different things like that. But anyways, you're going to get a set of comma-separated data, okay? You're going to need to set your working directory. So remember we talked about how to set your working directory. In this case, I set it to, I'm on a Mac, so I don't have the drive letter, and I set it to my home directory because that's where I happen to store this particular data, okay? And then I need to read this in. We taught you a couple different ways you can read in data. Again, I like to write things in scripts, so I definitely recommend doing it this way. Read it in. So here's my name of my file, cholesterol.csv, and I say, yep, the first row is a header equals true. Notice I didn't put in the separator because we know what the separator is at CSV. It already works there, so I don't need to set that. So I didn't bother. The next thing I'm going to do is I'm going to split into into a random set of test data and training data. So the first thing I need to do is I'm going to set the random number generator. I'm going to set it to a number I know. That way the next time I come in here, it's repeatable. It's always going to be the same group. So I'm going to say 70% of the data is going to be training, 30% of it's going to be test. Okay? So here we have a long command that is essentially multiple commands embedded inside of each other. So you see the C right here. Okay, that's your combine. Okay, and that's where you're going to put your 70 and 30, or whatever percentage you want to use. And you can carry this out further and further. 2 right here in sample is the number of data sets you want. In this case, I want a training set and a test set. Well, that's 2. Okay, number of rows. This is the number of rows inside of this data frame. Okay, my cholesterol data frame, which I read in right here from that CSV file. Okay, I don't know if you need to worry about replace. Just place equals true. And I'm going to store it in this variable end. Okay, so I'm going to run that command, and now I'm going to it's going to store everything in there, and then I'm going to put my training data is going to be in the first row, and so I'm going to put it in there, and then in my second one I'm going to put it into this one. So training and test. Again, it's just to teach you the syntax here. They're going to go through the specifics of why you're doing test and training sets and all that kind of stuff throughout the course. So don't worry too much about that. Just look at the syntax, kind of play with it on the command line, type these commands in. You should be able to just type in these exact things, and then try replacing some of my numbers with some different things and observe the results. Okay, that's the best thing I can tell you to help you through all this. Okay. Okay, the next thing you're going to do is you're actually going to do the linear model, okay? And so what we're going to do is we're going to set our formula, and so in this particular case, I want to know what, I'm going to predict for cholesterol based upon these other variables. And so in this case, the dot means something special. That means use all the other columns in order to predict this cholesterol. If I only wanted to use certain columns, what I would do is I would use this format here where I'd say age, plus, what was the other one? Phthalates plus resting heartbeats, however many I wanted to use. And I'd have to actually write them in by hand with a plus sign in between them instead of that dot right there. Okay? But in this case, I just want to use all of them. And so I'm just going to put the dot, and that's just a shorthand way of doing that. And then I tell it to use the training set of data. Okay? And then store the results in this variable results. Okay? Once you do that, then there is this command called step. Step is going to give you AIC. It's going to begin to figure out your variables of significance. Okay, and it's going to store the values into this results1, which is what I'm calling it. And if you'd like to see that, I printed it out here to show you what's being stored in there, and so it's going to store all that information. And then finally, you're going to do summary, which it's going to say, give me the summary results, and this is going to give you the values you really need, and it's going to give you the data that you're going to need to really produce stuff from here. And so this is the final results that you're trying to get to, and so you should see something like this. Notice I put that dot in there, and notice up here it actually put my formula in, as you can see up here. It actually put in age and sex and resting ECG and thalage. Okay. And notice this is after I did the steps, so it's not all the variables any longer. It's only a few variables. And so they're going to talk about what that means and why that's the case. And it has something to do with these stars over here that you're going to learn more about. Okay? Having said all that, I know we're going over just a little bit. And again, like I said, the professor is going to go over this a little bit more in depth. This is a good place for you to go to reference the syntax. There is a document coming that's going to go in depth into the linear model. It's going to tell you the linear regression. It's going to tell you a lot more about it. Here's some useful references for you. And just really, really quickly, obviously you guys can read this on your own. I'm going to do a demo really quick. So I'm going to stop sharing this. And I'm going to share RStudio. Okay. So here's RStudio. Okay. You notice I have everything kind of cleared out for us already. I start up here where I'm going to do an example math thing. Just 2 plus 5, maybe we should 7. Here I'm going to store it in variables, and so this is going to be available for you if you'd like. You can go in here, you can manipulate my stuff, you can play with it, but it kind of goes over the major commands that we went over tonight, and just kind of step by step. It doesn't do anything in particular, but it just gives you examples, and you can come in here and, like I said, play with this information, change my variables, change these numbers, and see what gets printed down below, and see how it manipulates things. Here is something we didn't go over specifically, but we talked about. I'm going to actually create a matrix. And then with that matrix, I'm going to print that matrix out here. And all of a sudden, you're going to see it's going to look kind of ugly. And then I'm going to give it some names to make it look unugly. And then I'm going to transform it, okay, into a data frame. Okay, so you can kind of begin to see how those things work. I thought I had an example. Oh, and here I have an example of a vector. This goes back to someone's question earlier. And here I have hello world is 2 different strings or 2 different characters, and I have a 1 and 2. And when you see test vector here, and we can actually do, you're going to see what comes back, and you're going to take a look at what comes back there. It may not be what you expect. So just take a really close look at that. And so I'm going to run this. The way you run this on a Mac is that you hit Command, Shift, Enter, and that'll run your entire script. I believe on a Windows computer it'd be Control, Shift, Enter. Although I could not swear by that because I haven't used Windows in years, so I'm sure one of your professors or your TA can help you with that. But I'm going to run, actually I think you can just hit run up here, but like I said. So I'm going to run that. So we ran all that script. You can see that this iris data got put up here, okay, and so here's my iris data. If I click on filter like I promised before, see how I can move the slider back and forth, and then all of a sudden it begins filtering data. See how it begins to narrow it down without actually changing what's in my data source. So that's what filter does for me. Notice I can sort, see how it's sorted differently, and I sort there by clicking on it. Notice over here, here's all my variables that are in memory, and these are the things that ran. And then over here are my plots. Notice I created this histogram of the cholesterol data, okay? And if I move the arrow, I also created a dot plot. And notice I put colors on my dot plot, okay? You can barely, but they're like green and blue and orange and things like that, okay? So you can see that information ran. Down here, you saw a lot of stuff being printed out. And so if we scroll up back through here, you can see, what each of those things, what each of the commands actually did along the way. Because what it's going to do, it's going to print, like in this case, here's step. And so here's the command that was run, and then here's the results of that command. It's going to print it right there for you. So you can, very quickly see what is going on with your code, and what kind of data is being put there. Again, because this data is still available to me, I should be able to do summary. I should still be able to use that data right here. And sure enough, I can. So because I had that cholesterol data frame still in memory, even though the program is finished executing, if I go down here in the console, I can begin, I can still, run commands over that same data set. Okay, or I can double click on it in here. If I double click on it in here, notice it brings up a table, like an Excel type table over here of that information. Okay, so it's a little bit different than other IDEs. Okay, history, you can see the history of what I ran. Okay, obviously it's not going to show you my script, but it should show you my summary cholesterol data. Yeah. Okay, so that is it I know this is a lot to take in. I try to keep it at an hour. We're a little bit over, so I'll go ahead and stop and ask if there's any questions at this point. I know it's a lot to take in though, in a single hour. But is there anything I can help anyone with, or any questions? Okay, well, if there's not, I'll turn it back over to Dr. Canode.
Thank you, Brent. I think that was excellent. I'm going to go ahead and stop the recording, and of course, all your professors will post the link with the slides in the classroom, so you'll be able to access, review, and go back through this, because it's a lot to absorb. We understand that, but I think you're off and running, and of course, there'll be a lot of other additional materials to help. So let me go ahead and stop the recording before I forget.